Hello everyone, welcome to this video on PySpark SQL's filter function. Today we will dive deep into how you can filter rows in a data frame using PySpark's powerful filtering capabilities. Whether you're working with simple conditions or complex expressions, this video will guide you step by step on how to effectively filter your data. We'll cover real world examples that you can use in your projects. So if you're ready to enhance your PySpark skills, let's get started. Introduction to the filter function. The filter function in PySpark is an essential tool when you need to narrow down the rows in a data frame based on certain conditions. It works by applying a logical condition to the data and keeping only those rows that match the specified criteria, removing everything else. This function is particularly useful when you need to refine large data sets by excluding irrelevant or unwanted information. It's quite similar to the way clause in SQL where you can specify conditions to filter the data such as comparing values, checking for nulls, or combining multiple conditions using logical operators. With filter, you can easily create a subset of your data frame that meets your analysis requirements, allowing you to work more efficiently with focused and relevant data. Whether you're dealing with millions of records or just a few, filter helps you clean up and refine your data frame for more effective data processing. Basic syntax. Syntax. The basic syntax for using the filter function in PySpark is dataframe.filter condition. In this syntax, the condition is any logical expression that evaluates to either true or false. This condition acts as the filter criterion for the rows in your data frame. Essentially, filter will retain all rows where the given condition is true and exclude the rows where the condition is false. The condition can be as simple as comparing a column value to a constant, or it can involve more complex expressions with multiple columns and logical operators like and, or, and not. This flexibility makes filter a powerful function when you need to refine your dataset by keeping only the rows that meet specific criteria. The syntax itself is straightforward, allowing you to efficiently filter and clean your data in a way that suits your analysis needs. How it works? Word. The filter function in PySpark operates by going through each row in the data frame and evaluating it against a specified condition. If a row satisfies the given condition, it is retained in the resulting data frame, otherwise it is excluded. This means that filter essentially acts like a gatekeeper, allowing only rows that meet the criteria to pass through. For example, if you are filtering rows where the value of a certain column is greater than a specific threshold, filter will keep only those rows that match this condition while discarding the others. This row by row evaluation ensures that you end up with a refined data frame containing only the information that is relevant to your analysis. This functionality is very similar to the where clause in SQL, making it straightforward to apply logical conditions and narrow down your dataset in a clear and efficient manner. Practical examples. 1. Basic filtering simple condition. In this example, we are working with a PySpark data frame containing employee information such as employee underscore ID, name and salary. We start by creating the data frame using the createDataFrame function and provide a list of tuples with sample employee data. Each tuple contains the employee's ID, name, and salary. The columns are labeled as employee underscore ID, name, and salary to represent the different pieces of information about each employee. Next, we use the filter function to filter out only those rows where the employee's salary is greater than 3000. The condition df.salary 3000 is applied to each row of the data row of the set that satisfy this condition are retained. In this case, we are selecting employees who earn more than 3000, which helps us focus on a subset of employees with higher salaries. The dot show method is then used to display the resulting filtered data frame. This use of the filter function makes it easy to narrow down the data to only the finite ambit specific area and discuss. Filtering in this way is particularly useful when analyzing data as it helps to focus only on the relevant subset, making subsequent analysis more manageable and meaningful. 2. Filtering using multiple conditions. In this example, we are using PySpark to work with a data frame that contains employee data, including employee underscore id, name, and salary. We start by creating the data frame using the create data frame function where each row represents an employee's details. The data frame includes columns for the employee ID, name, and salary, giving us a structured view of the employee information. To filter this data frame, we use the filter function to extract only those employees whose salaries fall between 3,000 and 4,000. Specifically, the condition df.salar with 3,000, df.salar with 4,000 is applied to each row in the data frame. Here, the operator is used to combine two conditions, one that checks if the salary is greater than 3,000 and another that checks if it is less than 4,000. Only the rows where both conditions are true are retained, giving us the employees whose salaries fall within this specific range. Finally, we use the .show method to display the filtered data frame, which now only contains employees with salaries between 3,000 and 4,000. This use of multiple conditions in the filter function is particularly helpful when you need to refine your data based on a range of values or apply complex logical filtering. It allows for precise control over which rows are retained, making it easy to work with the exact subset data that is most relevant for further analysis. 3. Filtering using string conditions. In this example, we are working with a PySpark data frame that contains information about employees, including their employee underscore id, name, and salary. We start by creating this data frame using the create data frame function where each row contains details for a specific employee. The columns are labeled accordingly to represent employee identifiers, names, and their respective salaries. To filter the data frame, we use the filter function to select only those rows where the employee's name starts with the letter J. The condition df.name.starts with J checks whether the value in the name column begins with the specified character, which in this case is J. This is a convenient way to filter the data based on a string pattern, allowing us to focus only on employees whose names match the given criteria. We then use the .show method to display the resulting data frame, which contains only those employees whose names begin with JJ. This type of filtering is particularly useful when working with textual data, as it allows you to easily extract records based on patterns or prefixes. By using starts with, we can quickly get a subset of data that meets the specific requirement, making it easier to analyze or perform further operations on only the relevant rows. 4. Filtering using isIn function. In this example, we are using a PySpark data frame that contains employee data, including columns for employee underscore id asterisk name and salary. We start by creating the data frame with a list of employee details for my build. Each row includes an employee's ID, name, and salary. Data frame provides a structured representation of the employee information. To filter the data frame, we use the filter function of the isIn method to select only those anecdotes whose names now match a specific list. In this case, we use df.name.isIn John Tom to filter the rows where the named column matches either John or Tom. The isIn method is very useful when you need to filter rows based on multiple values, as it allows you to specify a list of options, making the code concise and easy to understand. Finally, we call the .show method to display the filtered data frame which will contain only the rows where the employee names are John or Tom. Using esin provides a convenient way to filter data by matching column values against a set of possibilities, making it especially handy when dealing with categorical data or when you need to extract specific records from your data frame. This approach helps ensure working with a targeted subset of data that meets the requirements of your analysis or processing tasks. 5. Filtering null values. In this example, we are working with a PySpark data frame def underscore with underscore null that contains employee data, including employee underscore aid name and salary. The data frame has some missing values nulls in the salary column, which is a common scenario when working with real world data that might be incomplete or have missing information. We create the data frame using create data frame. One of the employee records, Jane, has none for the salary value, indicating that this information is not available. To filter the data frame, we use two separate conditions. First, we use diff underscore with underscore null dot salary dot is not null within the filter function to select rows where the salary is not null. This effectively keeps only those rows that have valid salary information. The dot show method is then called to display the filtered data frame, which includes employees with a non-null salary John and Tom in this case. Filtering out null value is especially useful when you need to perform calculations or analysis that requires complete data, ensuring that missing values do not interfere with your results. Next, we use df underscore with underscore null dot sailor dot is null within the filter function to select where the salary value is null. This keeps only the rows where the salary information is missing, which can be useful when you want to identify incomplete records for data cleaning or imputation. Again, we use .show to display the filtered data frame, which contain only the rows where the row salary is not available, Jane in this case. These examples demonstrate how PySpark makes it easy to work with missing data by providing functions like isNull and isNotNull. These functions help you handle null values effectively either by excluding them when performing analysis or by focusing on them when you need to address missing data issues. 6. Filtering using SQL-like expressions. In this example, we are using PySpark to filter rows from a data frame containing employee information. The data frame def includes columns such as employee underscore aid name and salary. We want to filter the data based on specific salary conditions to get only a subset of employees whose salaries fall within a particular range. To accomplish this, we use the filter function with the SQL-like syntax as the condition, salary 3000 and salary 4000. In this case, the filter condition is provided as a string, making it similar to the where clause in SQL. The condition filters out rows where the salary is greater than 3000 and less than 4000, retaining only those rows that meet both conditions. This approach of using SQL-like syntax can be especially useful for those who are comfortable with SQL, as it provides a familiar way to express complex filtering criteria. Finally, the .show method is used to display the filtered data frame, which will include only those employees whose salaries fall between 3000 and 4000. Using SQL-like syntax with the filter function can make the code more readable and intuitive, especially when dealing with multiple conditions or when trying to replicate SQL logic directly in PySpark. It provides a powerful yet straightforward way to work with data by combining the flexibility of data frame operations with the familiarity of SQL expressions. 7. Filtering with complex expressions. In this example, we are working with the PySpark data frame that contains employee information, including columns for employee underscore add name and salary. The goal is to apply a complex filtering condition to extract a specific subset of the data based on multiple criteria. We use the filter function to achieve this, applying two conditions simultaneously. The first condition checks if the employee name is Tom, while the second condition checks if the salary is greater than 3000. To combine these conditions, we use the AND operator, which ensures that both conditions must be met for a row to be included in the filtered data frame. In PySpark, using is equivalent to using the AND operator in SQL, allowing us to filter based on multiple logical conditions. In this case, only employees named Tom who have a salary greater than 3000 will be retained. Finally, we call the .show method to display the resulting data frame, which will include only the rows that match both conditions. This example demonstrates how PySpark's filter function can be used for complex filtering involving multiple criteria. By combining conditions with logical operators, you gain precise control over which rows are included in the output, allowing you to focus on very specific subsets of data that are relevant to your analysis. This kind of filtering is particularly useful when you need to extract data based on multiple characteristics, such as a combination of names, numerical thresholds, or other attributes. That's it for today's video on the filter function in PySpark SQL. I hope you now have a solid understanding of how to filter rows based on different conditions, whether simple or complex. Don't forget to experiment with these examples in your own projects. If you found this video helpful, make sure to like, share, and subscribe for more PySpark tutorials. Feel free to drop any questions in the comments below. See you in the next video.